So, let us take the next property, that is base catalyzed condensation reactions. In this there are 4 prominent reactions are there: aldol condensation and Cannizzaro reaction, benzoin condensation, Perkin condensation. In addition to this, there are some similar type of the reactions also that we will cover later, but let us take first the aldol condensation. Aldol condensation. All these are condensation except Cannizzaro reaction is not a condensation, it is an oxidation reduction. That is why we say Cannizzaro's reaction, not condensation. Aldol condensation, benzoin condensation, Perkin condensation, but the Cannizzaro reaction is a oxidation reduction reaction. That is why it is called Cannizzaro's reaction. So, aldol is a condensation reaction. What exactly taking place in this aldol condensation? The conditions for the, that is under what condition the reaction takes place, also it is important. Conditions for this reaction is first the both aldehydes and ketones undergo this reaction. Both aldehydes and ketones, but having 2 alpha hydrogens. This is the first condition. A carbonyl compound should contain alpha, means the immediate carbon is called alpha carbon, on which 2 hydrogens should be there. This is the condition I want. First condition is it can be aldehyde or ketone, that is not restriction. You can have an aldehyde, even ketone. In Cannizzaro only aldehyde, that type of the condition is there for Cannizzaro, but not for the aldol. Both are eligible, but you must have a immediate to the carbonyl group. Next carbon is called alpha. Leave the functional group, alpha, beta, gamma, delta, that is the nomenclature. On the alpha you must have 2 hydrogens. So, having 2 alpha hydrogens are only eligible. Second condition is a strong base is needed. A strong base is the another condition. Generally 50% either sodium hydroxide or potassium hydroxide is the prescribed base, but rarely we have some questions with the calcium hydroxide or barium hydroxide also the questions are coming, but basically the 50% means very highly. Generally dilute NaOH means 10% NaOH, beyond that 10 we say concentrated, but here it is the 50% means half of the sodium hydroxide, half will be the water. So, really it is very highly concentrated base should be the actual requirement. So, what happens exactly means the aldehydes and ketones. So, first one aldehyde I will give one example is, let us take acetaldehyde is the one simple example, isn't it? Whereas, if you take formaldehyde, that is according to this non-eligible also you can notice like an aldehyde which is having a no alpha carbon. So, therefore, this is not eligible according to the condition. And similarly, if a carbon is there, alpha carbon is there, but alpha carbon is occupied by the methyl groups like this is not eligible. Similarly, alpha carbon is there, but it is attached to a aromatic carbon, that is double bond and single bond where there is no hydrogen. Like that we have a huge number of compounds which are not eligible for this aldol we have. So, here I have given an example. This is a small compound which is eligible because an aldehyde, it is containing the 3 hydrogens, it is eligible. So, therefore, this compound taking this, let us see the mechanism. A strong base is added and a slight heating, if you do it, what happens? This one acetaldehyde add 2 acetaldehyde will react, and finally what happening is CH3 CH double bond CH is formed. This is the final compound. That means 2 carbon compound has become into the 4 carbon compound. So, 2 compounds is joined, it seems. So, that is why we call it is a condensation. And the joining is also specifically, if I write like this, a CH3 C double bond O with what hydrogen, this side 2 hydrogens and 1 hydrogen right it top and a CHO. If I put a box type of the reaction, then the CH2 and O, these 2 are eliminated as a water. So, what we get is a double bond between the 2 given acetaldehydes. So, that is what is shown here as a minus of H2O. So, a small mechanism may be offered during this process of this reaction. H2O is removed. So, therefore, this is called formation of water if I claim as a condensation. So, I call this reaction as a condensation. But exactly this is not the whole mechanism. The mechanism is slightly little more complicated than what we see. A box is solved this problem, that is H2 and O is gone and this is formed. What more mechanism you require? That is what they actually, really speaking, this is has got slight a different mechanism when you see the actual mechanism of this reaction. So, let us see the mechanism of this aldol condensation. In this mechanism, it's also we can make one point, the role of the base or the OH minus, what exactly the OH is doing. Just like in the Fiddlecraft alkylation, acylation, we used aluminum chloride. It holds the Cl minus of Rx when treated. X minus will be held with this aluminum chloride and the R plus is generated. Like that here also, an acetaldehyde, if I take one of the alpha hydrogen, which is originally showing the hyperconjugation, therefore detachable as a H plus. That means this particular hydrogen has originally some slightly detachable quality of as a H plus, means it has acidic property. So, this acidic proton is taken away by the OH minus. So, the H plus is withdrawn by this OH minus and leaving the electrons to the carbon only. So, therefore, what you will get is there is a minus charge is formed on the carbon, and this minus charge has got some resonance stabilization, therefore, readily formed, and this H and the OH forms into water. Now, this is called a carb anion. So, this will be the observed also as a slow step, or it is also called a rate determining step. Rate determining step or RD step, it is called. Several times this type of questions are coming. There will be different steps I will write and ask which is the rate determining step. In a reaction, if several steps are there, one of the step naturally will be the little slower step considerably. That slow step is called rate determining step. That means, when once that step is over, other reactions are fast. So, that also will be considered to be a closure. So, therefore, though that step is first initially or middle or at the end, slowest step will be the rate determining step. If that is over, the other steps are relatively over. So, therefore, it is considered to be the rate determining step. So, the removal of the proton is only the delayed step. Once this carbanion is formed, the second molecule of this first molecule converted into anion. Now, you take the second molecule and have a open up that this carbonyl group is now shown like a if you open into minus and plus, there will be a carbocation will be there, right. This is only just a polarization. So, or you can write the polar, the structure itself you can show it as another carbonyl group compound is shown as a minus and plus. Let us take this is the acetaldehyde with an open structure. Now, there is a carbocation is there. So, this carbanion will come and attack on this carbocation. This should be the fast step because it is totally ionic step. So, carbanion initially formed will attack on the carbocation of the second molecule. This will be the ionic step, therefore, logically it is very fast reaction. So, what you will get is CH3, C will become a O minus, and now this is the first acetaldehyde, another first acetaldehyde is joined here, CH2 CHO. So, this step makes the larger molecule, two molecules are joined together through the carbon-carbon bond. This bond is called a new CC bond, synthetically very identity, that is significant bond. So, thereby the two molecules are joined. Where it is joined means the alpha carbon of the first compound, then carbonyl carbon of the second molecule is joined. This is the carbonyl carbon, this is the alpha carbon of the first is joined. Now, this is a alcohol anion. This alcohol anion and the water together, if you keep, the alcohols are stronger bases. Then this compound gives a proton, what is formed is OH minus. So, immediately what happens among these two, there is a proton exchange will be taking place. So, let us write this step as a H plus a exchange between what, between this alkoxide and the water. So, this will become into the alcohol. What alcohol it is? With reference to the carbonyl compound, the OH is beta. So, it is called beta hydroxy aldehyde or ketone is formed, and this proton will be exchanged from this water to this one. So, again the water will become into the OH minus. So, see the role of OH minus, initially it holds the proton, temporarily has become into water, again the proton is given back. So, the OH is generated. So, the concentration of the OH initially what we have taken will be restored back. So, the concentration will not neither increase or decrease. Now, this compound has become a beta hydroxyaldehyde. So, beta hydroxyaldehyde, this OH group originally will have some outgoing property because of the electronegativity. Now, here there is one hydrogen, here also there is one hydrogen, even there is a hydrogen that is alpha, but two beta hydrogens, which beta hydrogen readily will be taken away and water is removed means this hydrogen is under hyperconjugation. Therefore, this hydrogen will be detached and the two electrons will come and the OH will be minus. The minus and the H plus will go out. That is called minus of water, is called dehydration. Dehydration, what conditions required means, in general concentrated sulfuric acid with 350 degrees is the right answer, but now we are maintaining a strong basic medium, right. Throughout this reaction is the strong base, 50% KOH means very strong base. Now, you cannot have a concentrated sulfuric acid and promote this second step. Instead, better is one is heating, that is always when you heat it, the water boiling point is 100. If you heat beyond the 100, automatically the liberated water goes out into the not into the equilibrium, it goes out of the equilibrium means the reaction goes on promotion. Or otherwise you can have some salts like anhydrous sodium sulfate, Na2SO3, SO4 sulfate you can have, or magnesium sulfate, MgSO4, or all are this anhydrous salts. When you add, when water is there, they take and become into hydrated salts. So, this salts adding is the more ideal than the going for the concentrated sulfuric acid. All of a sudden the basic medium will turn up into acidic medium, a lot of heat will be generated, the reaction may be slightly diverted even. So, therefore, better is first step is base you add, after some time when you are heating add some this anhydrous salt, so that the water is taken away and the compound will become into alpha beta unsaturated carbonyl. With reference to the carbonyl group, this is alpha carbon, this is beta. So, the answers are described as alpha, beta, unsaturated, the aldehyde or ketone is formed. In between, what you get is called beta hydroxyaldehyde, or this is called aldol. So, on the way you got an aldehyde containing ol, somebody named this aldol is formed, therefore, the reaction is said to be aldol condensation. But the condensation net is this removal of the water from one acetaldehyde O, another acetaldehyde, 2 hydrogens if you remove. Net reaction is a aldol condensation, but up to this alpha hydroxy carbonyl compound formation is called aldol addition, that is aldol formation. So, the first step is a nucleophilic addition. The molecule splits up into alpha hydrogen and the rest of the molecule anion. The anion adds on the carbon and the proton adds on the O. So, therefore, this type of the nucleophilic addition followed by the elimination, net is a condensation reaction. So, the aldol condensation involves, no doubt it is a net reaction is condensation, but first step is the carbonyl compound splits up into the alpha hydrogen plus and the rest of the molecule as an anion. So, the anion first attack, because it is a nucleophilic addition, anion first attacks on the second molecule of the carbonyl compound carbocation and the proton adds on the O. So, therefore, O will become OH and the entire molecule is added on the carbon of the first molecule, and its a nucleophilic addition is over. Second step is elimination step. So, the condensation is nothing but a addition followed by elimination, net reaction is this one, or otherwise one can show like this: first molecule O, right, second molecule 2 hydrogens, you write the hydrogen this side, 1 hydrogen that side. So, 1 acetaldehyde O, 1 acetaldehyde, 2 alpha hydrogens, remove it, you will get this alpha beta unsaturated carbonyl compound. So, you identify that this bonding alpha beta unsaturated means a double bond containing carbonyl compound. Vice versa, you can also understand, for example, some X compound in basic medium, this compound is formed. This compound has a alpha beta unsaturation. You cut this compound into 2 pieces between alpha and beta, add hydrogens to this side, O to this side. If you add O to this side, 2 hydrogens, that is removal of water, is this molecule is formed. So, what you add, get back the original compound is again water. How you add means, don't add O this side. If you add O, already O is there, 2 O's this side, this will become ethane. Ethane will not undergo condensation, that hydrogens are not reactive. So, you meaningfully you add, that side you add hydrogens, 2 hydrogen, this side if you add O, you will get acetaldehyde and acetaldehyde, that means 2 acetaldehydes eliminated water. So, any alpha beta unsaturated carbonyl compound if you find, that you can guess that is formed by the condensation of a 2 carbonyl compounds by removing alpha hydrogens from one compound, oxygen from another compound by removal of the water, or like this. Actually, this is called a condensation, but the condensation as such, there is no such reaction in the organic chemistry. Condensation is not a primary reaction, just like 2 primary colors, if you add some pink color, or the secondary colors are produced by adding the primary colors, like that. Condensation is a secondary reaction. Primary reactions are addition, elimination, substitution are the primary reaction. So, in this condensation reaction, first reaction is a addition reaction, that is nucleophilic addition. One carbonyl compound adds on another carbonyl compound, getting this beta hydroxy compound, from which elimination of HOH leads to give this double bond. So, double bond formation directly will not come out of the condensation, because condensation is a no more it is a primary reaction. First nucleophilic addition of one carbonyl compound over another carbonyl group, then a beta hydroxy compound or an aldol is formed. Unfortunately, this was studied by an aldehyde, therefore, aldol is named. But the reaction is also studied, even ketones undergo this type of addition to get a ketol, then followed by this the unsaturated compounds. But the reaction is said to be that even ketones undergoes condensation, is also called as a aldol condensation because of the first acetaldehyde was studied. And it is also studied, once this compound is formed, it will not stop. This carbonyl group will condense with another acetaldehyde, and one more alpha beta unsaturated is formed. Like that, acetaldehyde, a long chain of gummy type of substance is formed. In fact, practically, if acetaldehyde is taken, added some base and then heated, a very long chain of acetaldehyde is joined. You get a resins formation actually. But why this is then when acetaldehyde heated with base, what happens? We write this and leave it. Taken grant that the basic skeleton reaction, we write two compounds undergo the reaction and leave it. Understood that it undergoes further reaction, but the first step mechanism we write and leave it. That is the minimum complexation we are representing. Similarly, the bigger compounds like other compounds, what happens? Let us see. For example, if acetone is taken and treated with the base, what happens? This is an acetone, a ketone, and treated with the OH minus and heated, that is strong base. This condition is enough, need not to be very specifically the KOH 50% not necessary. This is enough to write the condition of the aldol. Now this undergoes, because there are alpha hydrogens are there, 3 alpha hydrogens are there, this side also 3, in fact 6 hydrogens are present. So we need only 2. So to get the answer, I will give one method. You write one carbonyl compound one side, and another same compound you write hydrogens this side. This is acetone, that is acetone. So we need this particular grouping. First carbonyl compound O, second carbonyl compound, same compound, with the 2 hydrogens I have written this side. A box mechanism may be applied in order to get the answer very simple or in a easier way. So write this molecule now like this. So this is your acetone, first acetone, and then another acetone is this one. So this is your answer. However, the reaction, as I said, it won't stop here. Some more the acetones may be joined. So the further addition may have this first molecule formed is called having a synthetically, you can IUPAC name, you can go 1, 2, 3, 4, 5. It's a pent 2-one, but having a third carbon ene. So pent 3-ene 2-one containing 4-methyl. So systematically it is said 4-methyl pent 3-ene 2-one. This is the systematic nomenclature of this compound. However, it is named as a mesityl oxide. Mesityl oxide. All these aldol condensation products are the reaction with base carbonyl compound, nothing to do, just add some base and heat it. So the compounds are much earlier to this IUPAC nomenclature establishment. The compounds are identified. They were well utilized in the medicines and different industrial applications. Therefore, they have used this common names. So common names have become so popular in the aldol condensation products. So mesityl oxide may undergo further the addition with the next mole of the acetone, may undergo different types of the reaction. One is one acetone in a symmetrically, that is one acetone plus one more acetone plus one more acetone, and so on, a long chain of this is one acetone, this is one acetone, one more acetone, like this. It may continue. In fact, a big polyacetone may be formed, or the reaction may be stuck up and then the reaction may be given like this. One acetone in the center, is other side one more acetone like this. This is a stuck up product is called 4-one. It has a commercial name 4-one. Even sometimes what happens when this mesityl oxide in acidic medium, if it is treated, it may undergo cyclically, and then a well known compound benzene with the 3 methyls in the 1,3,5 system, it is called mesitylene. The 4-one and this the mesitylene, it is also called as 4-one or 4-one, fourth carbon one is there, so somebody said it is 4-one. It has a commercial name mesitylene. Mesitylene means 1,3,5 trimethyl, that is one more acetone comes and cyclically it comes out. This will become a methyl, this will become a methyl, one more methyl will come, and a chain of a 6-membered ring is formed. The chain cyclizes and then undergoes 3 acetones, this is 1 acetone, this is 1 acetone, this is 1 acetone, will become into the cyclically mesitylene is formed. But the second step is acid catalyzed with dilute sulfuric acid, mesityle oxide with dilute acid will become into aromatization, or it may go this type stuck up type of the products, 4-ones are formed, or polyacetone also may be generated. That is all complication, will have a never ending story. So, lot of complicated reactions will be explained. But in the first stage, acetone with base, what happens means right up to at least mesityle oxide, and then say one carbonyl compound O, another carbonyl compound, 2 alpha hydrogens are condensed, and to get this type of the reaction. The mechanism you have to explain first. The hydrogen is detached and you get an anion. That anion will go and add on the another carbonyl compound, and a nucleophilic addition followed by elimination leads to this type of the product. A typical question is, for example, if a 5 carbon aldehyde is treated with the base and then heated, what is the answer means? One carbonyl compound O, another carbonyl compound, same compound, 2 alpha hydrogens, means I have to write like this: one carbonyl compound O, another carbonyl compound, 2 alpha hydrogens. That means this is the carbonyl compound, and the remaining 3 carbonyl groups you write down, so that the reaction is correct. The concept is very clear. One carbonyl compound O, another carbonyl compound, 2 alpha carbon hydrogens will cut. Why not the last hydrogens? Because alpha hydrogens show hyperconjugation, or acidic or inalizable tautomerizable hydrogens only undergo aldol condensation. That is why you need to that to only alpha carbon hydrogen. Therefore, you have to write like this: second carbon is added. So, therefore, you will get a 5 plus 2, a 7 carbon compound is formed, and the double bond is between the second and the third carbon of this carbonyl group. And here 3 carbons will be hanging. This is 1 carbonyl compound, this is 1 carbonyl compound. So, therefore, what will be the root word of this compound when you do apply the longest chain means the longest chain of this 2 carbon plus this 5. So, total will be the 7. I have taken actually 5. You won't get a long chain of 10 carbons. However, maybe this is the longest chain, but when you apply the IUPAC nomenclature, 1, 2, 3, 4, 5, 6, 7. So, a 7 carbon aldehyde containing on the second carbon a N propyl group, and second, third there is a double bond. So, 2-ene it is, isn't it, 2-ene, and then this double bond is there. So, therefore, you have to apply this nomenclature and then say this is a hept 2-ene all, it is a heptanol is formed, and 3-methyl hept 2-ene aldehyde is formed. So, this is what the reaction, whenever a carbonyl compound is given, it is very clear: 1 carbonyl compound oxygen, another carbonyl compound, 2 alpha hydrogens undergo reaction. Okay, right. Now, if 2 different carbonyl compounds like acetaldehyde is mixed with propanaldehyde, let us call this as A, this as a B. So, this is called what? A mixed aldol condensation. Mixed aldol condensation. Then if A and B is treated, naturally you may get a condensation between A and A, or a B and B, or A and B and B and A. Now, here A, B are different from the B, A. So, all the 4 types of the compounds are formed, and how these structures are written means acetaldehyde plus acetaldehyde, let us write like this. This is acetaldehyde and acetaldehyde answer, A and A. B and B is when you write this side B is okay, but this side B when you write, you have to show that the alpha hydrogen is condensed. This is with B and B. A and B means this is acetaldehyde, that side is propanaldehyde, right. So, this A and B. B and A means B will be the straight B carbonyl group, and again A carbonyl group. A carbonyl is acetaldehyde. So, these all the 4 compounds are different naturally. A question may be asked, out of these 4, which compound may be the major product? That means when I add base, which of these 2 compounds undergo readily the proton removal? here 3 hydrogens are there, here 2 are there, and one of this side is minus I and hyperconjugation, this side plus I is there. So, the reactivity of this hydrogen is relatively less when compared with the hydrogen. So, therefore, when base is added, first the acetaldehyde proton will be removed. So, you will get an anion of acetaldehyde, which will go and attack on the 2 types of the compound, and which is more reactive, means again once again smaller the aldehyde undergoes nucleophilic addition faster. Therefore, acetaldehyde first undergoes loss of proton, becomes carbanion, go and attack on the acetaldehyde only. Therefore, AA may become the major product theoretically. So, rest will be the minor. Okay. So, acetaldehyde forming into carbanion has a favor point, and that anion attacking on the again on the acetaldehyde has a favor point. Therefore, so acetaldehyde attacking on the acetaldehyde will be the major, rest of the other compounds will be the minor product. This is called what? Mixed aldol condensation. Similarly, we have another type of aldol condensation. This is between the 2 different types of the carbonyl compound, both are eligible to undergo aldol condensation. The benzaldehyde, which is actually has no alpha hydrogen, but this can condense with the acetaldehyde alpha hydrogens. This type of condensation is not only mixed, but this is not eligible for the aldol because it has no alpha hydrogen. Alpha carbon is there, but it is involved in the aromatic. So, one non-eligible, one eligible. However, one more hydrogen is there, but I will write this hydrogen this side. Okay. So, this 2 hydrogens, this is eligible aldehyde, this is non-eligible. So, one eligible, one non-eligible, if I mix, this is also an aldol condensation, but we say this is a in between 2 different varieties. It is specially called a Claisen-Schmidt condensation. People also say it is crossed aldol condensation. Crossed aldol means one eligible, one non-eligible for aldol. This is the specifically, some books are specifically mentioning at least one of these carbonyl compound, one non-eligible, one eligible if undergo aldol condensation, that is said to be a Claisen-Schmidt condensation. In this case, a benzene with CH double bond CH-CHO is formed, which has a specific name called cenamaldehyde. So, benzaldehyde and acetaldehyde giving cenamaldehyde. Similarly, formaldehyde. Formaldehyde is also not eligible, but acetaldehyde using the 2 alpha hydrogens may condense. So, therefore, you have a formaldehyde and acetaldehyde. It is a mixed type, but one non-eligible, therefore, it is called Claisen-Schmidt condensation. The product is called acraldehyde or acrolein. Acrolein or acraldehyde is formed. So, the formation of this type of mixed type of the reactions, specifically one is non-eligible, is called Claisen-Schmidt condensation. We have slightly different condensation. For example, if 2 propanaldehydes are condensed, you may write a reaction. If I write like this, how do you show the condensation? Means hydrogens of one carbonyl compound and O is of one carbonyl compound is undergoing condensation. There develops a double bond formation, right? This is what you have to write the answer. So, 3 carbons with the carbonyl group, okay. That carbonyl is going now to make a double bond. So, therefore, let us write the double bond between the second carbon here. So, there won't be a CO, that O is making double bond with this carbon. However, here the aldehyde will be there. This is the answer for the if 2 compounds are propanaldehyde. But instead of 2 propanaldehydes, I have now a compound, a connection is there between the 2 carbons. This is no more a 2 compounds, it is a single compound containing hexane diol, 1, 2, 3, 4, 5, 6 carbon hexane diol. So, need not to show 1, 6. If you say 1,6 is good, but it is not a IUPAC system, is not necessary to show that unnecessary numbers. Simply you can say hexanediol. Where are these diols means aldehydes will be definitely on one and the other end will be the. So, it is also having a common name. Hexane dioic acid is called adipic acid. So, you can say adipine dialdehyde. This adipine dialdehyde on a reaction, this is a double bond is there. So, this double bond formation as it is, but it is a single bond, extra bond is the connection. So, this is the compound which you can write is a 5-membered ene, isn't it? It is a 5-membered ene. Adjacent there is an aldehyde. Now, recognizing this product as a aldol condensation, I said with reference to the carbonyl, this carbon is alpha, this carbon is beta. So, verify that this compound really alpha beta unsaturated aldehyde or ketone? Yes, that is the alpha beta. So, therefore, the reaction is right that absolutely that 5-membered ring containing double bond adjacent carbonyl. So, with reference to the carbonyl alpha beta unsaturated. So, this is nothing but this only, just a little artistically written, a 5-membered, that is cyclopentene containing aldehyde. So, one carbonyl compound O is condensed with the 2 alpha hydrogens of this compound, eliminated water, this is the product. The reactions with the aldol condensation involving this type of reactions you may claim is also intramolecular within the compound, isn't it? So, you can call it as a intramolecular aldol condensation. Fortunately, this type of intermolecular condensations have no specific name, whereas in some cases like intermolecular Woods reaction we named as a Freund reaction. Intermolecular Claisen condensation in the case of esters, we had a name like Diekmann condensation. Here, intermolecular aldol condensation has no name, simply within the molecule the condensation leads to give the the alkene attached to a carbonyl group, which can have a one more specific example. For example, if there is a cyclohexene, the cyclohexene having 2 carbons also can be taken like this. This is the 1,2-dimethyl 1-cyclohexene. This is an ozonolysis followed by hydrolysis in presence of the zinc. Then what you will get is a carbonyl group and a carbonyl group is formed, right? This is CH3, this is CH3. Now, this compound is treated with the base and then asked what this may be claimed as a compound X treated with this one, a is formed. A on treatment with this one, a B is formed. What is A and what is B? Both can be questioned. A is already I have shown because the ozonolysis, this is zinc means reductive ozonolysis, it cuts and you will get both the sides. So, now the carbonyl compound, 2 carbonyl compound, if it is not there, it is nothing but the butanone, 1, 2, 3 for butanone, butanone. It is attached now. So, therefore, intermolecular aldol condensation takes. What is intermolecular aldol condensation? One carbonyl compound O will go out, and with that O what is going out means you have a chance of elimination that side CH3, okay, one chance, this side CH2, there are 2 hydrogens are there, there are 3 hydrogens, which side elimination is the question. If this side goes, we will get a ring of 1, 2, 3, 4, 5 carbon ring, and this methyl out, this acetyl out. Otherwise, if you include this side, you will get a 5 plus 2, 7 carbon ring, and then 1 methyl will be out. So, there are 2 types of chances are there. Let me write a 5-membered ring. A 5-membered ring is formed, 1 methyl will be out, and there is a double bond is there, okay. This carbonyl group is attached to this one, and there is a C double bond O CH. This is one answer. So, one carbonyl compound CH2 is going with this one. Or you may have another chance, a 7-membered ring is formed. A 7-membered ring is formed, only 1 methyl will be out. So, a carbonyl compound is attached with the like this. So, here this is also with reference to this carbonyl alpha beta unsaturated carbonyl, with reference to the carbonyl alpha beta, both are correct, but this is a 5-membered ring, this is a 7-membered ring. Which is more stable means generally 5-membered is better one, 6 is the most stable, but when 6 is, when compared with 5 and 7, 5 is the better one. So, the 5 membered one is the major product formed here. Another reason also you can offer, okay, that is better, that ring itself is the deciding factor here. Instead of the terminal hydrogens, you can take here hydrogens and go for this type of the major product will be this one. So, intermolecular, this is again a intermolecular aldol condensation, just a base and heating is enough to get. If heating is not there, sometimes just addition product, that is aldol, may be written, but whenever heating is there, the loss of water, that is total condensation, you have to answer. So, this is also one unique example for the first the carbonyl compound formation and then aldol condensation together may be asked as a little bigger question it is.